Yes, we are live now. So I welcome Srijit as for this webinar. This is a kind of a webinar where we are actually seeing the blend of machine learning and the DevOps environment. We have actually seen how the technology has evolved over the course of time, and we have also seen how things are literally being designed in the ML space. It's not about the neural network architecture, it's not about the data set, it's also about the process which we are encountering over the process of building such model. So I welcome Srijit as sir for this amazing webinar on MLOps using Azure. So thank you for giving this great webinar for us, sir.
Okay, thank you, Vishwas, for welcoming me. Hi, all. So today we will be talking about Azure MLOps, and this will be our agenda. We will just talk about what exactly is machine learning operations because there are a lot of myth around what exactly is MLOps. A lot of people are confused about MLOps with some other things. So we will try to clarify what exactly is machine learning operation in its broad sense, and then we will come to know about what are the different machine learning components, MLOps components, which Azure offers. Then we will talk about how we can club machine learning operations with the DevOps, Azure DevOps together so that we can build a continuous integration and deployment pipeline on top of your machine learning project. Then we will have a fully automated, I can show you a CI/CD pipeline, which I built using a sample data set in a machine learning project, where we can see a completely automated end-to-end CI/CD pipeline using DevOps and making use of all the components of Azure MLOps. Okay, so I might not be able to completely show the demo because of my issues with my Azure subscription, but I can share as much as possible. Right. So first comes to the machine learning operation, right? So some people say that machine learning operations or MLOps is DevOps is equal to DevOps, but it is not. And some people say that MLOps means it's a data centric approach, then a model centric approach. No, it's not. So in my term, in my understanding about different platforms like Azure Machine Learning or SageMaker, the machine learning operations is fundamentally it's an end-to-end lifecycle management of a machine learning project. So MLOps is not only DevOps, MLOps is not only data-driven approach, it's much more broader than what you are thinking, right? So MLOps handle each and every part of your machine learning project. What are the different modules in your project, and the machine learning operations will be able to manage that in an organized way. So as we know, right, so the traditional machine learning project, or if you look at the traditional normal software development project, there are a lot of practices, best practices, and a lot of structured way of doing the things. But when it comes to the machine learning project, there is no such structure, and there is no best practices in terms of an organization way. So usually what we do is we just open up a Jupyter notebook and we bring the data into the local system, and we write a lot of experiments in that Jupyter notebook, and we create a model, and that model will be shared to the DevOps team, and they will build a pipeline, or they'll just deploy it as a Rust endpoint using some Python, Flask, or that kind of an APIs, right? In this whole process, our primary focus, usually every data scientist's primary focus is how to build a best model, right? So that is the primary focus. So data scientist doesn't much focus on how to organize your data, the training data or the raw data what you're receiving, how to organize your experiments, what you're doing in your Jupyter notebook, how to reproduce that experiments, how to keep track of that experiments and create a lineage between all the different modules in your machine learning project, and how to effectively deploy that model into different environments like your dev environment or QAT or prod environment, etc. So how to seamlessly build a pipeline, or how to seamlessly organize all these modules together so that you can bring your data and you can organize your data, you can have your model building experiments, and you can even track each and every experiment, and what you can trace what is happening in that experiment. You can manage your models if you're building a lot of models in your organization, or as part of your machine learning project if you're building a lot of models, how to organize it in a well mannered way, instead of simply keeping everything in your local machine and Jupyter notebook, where it makes impossible for the business to trace what you're exactly doing. So what they actually see is a model which is coming out of your experiment. Whatever you do with respect to the data, with respect to the model, with respect to the experiment, everything is completely a black box for the business, right? So they can't even come to that part, and they can't even trace what exactly happening. So even after some time, right, you will not be able to see what exactly I have done on that experiment, because you are not logging any information about that experiment. What you're exactly logging is everything is in your brain. So where did I get my data? Where did I store my experiment, etc.? Everything in my local system. Everything is in your brain, right? So that is not going to happen in an enterprise world, right? So everything what you do should be transparent, it should be reproducible, and it should be easily and seamlessly manageable, so that enterprise can take it further, right? So that's a fundamental idea of machine learning operation. So how to bring this kind of a process in each and every module to in your machine learning project, how to bring the process around it, so that everything becomes very transparent and it is very extensible and scalable in future, right? That's what the basic fundamental of what exactly is ML operations, and what is the basic job of MLOps. It is not DevOps. It is not data centric approach. It is much more than that. It is bringing an organized pipeline to your machine learning project. In this diagram, what you see, some of the common modules which we usually do in a high level in a normal machine learning project. We usually have a code management, right? We have to connect to a central code repository, and we have to sync all our development with the central repository code, Git integration. But usually nobody does this, right? So data scientists will always remind their code. They will keep all their code in their notebook, and everything is very local to not the data scientist. They usually don't connect to this code repository, and they will not sync this notebook with the code repository, etc. So that phase we should do. And coming to the data management, as part of our machine learning project, we will get a lot of type of data, right? So we'll get the raw data, and we clean up that data, and we have a clean data, right? Then we have a trained data and the test data. We have a feature engineered data. All this type of data we are dealing with, but we are not organizing it, and we are not versioning it, and we will get incremental and full load data. So we are keeping everything in our local machine or wherever our Jupyter notebook is, right? So that is not a proper way of organizing the data, right? So how to manage data versioning for your different data types, and how to keep your data in a central location. So that's what we call it as data management in MLOps. So using MLOps, we can efficiently manage all this type of a data with the different versioning and different incremental or full load, whatever type of data it is, in a central location. So everything is completely transparent and traceable. So you can go back to that data central location at any point in time, and you can see what has happened with that data, what I applied on top of the data, what exactly is that data, etc. So for sometimes, right, if you wanted to go back to some older version of the data, if we haven't kept it in our local, it is difficult for us to retain that data, right? So data has to be properly managed. So that's why what I meant it as data management. So that is possible with MLOps. And then comes to the model building part. So in the model building, right, we usually do a lot of experiments. So each and every experiment create a lot of logs, metrics, artifacts in terms of outputs, plots, the metrics plot or whatever plots which you can build as part of your machine learning experiment. And we are not logging it anywhere, right? So we have to log all that things into a central repository, so that at any point in time you can go back and look at that central repository, where you can see all the logs about a particular metrics, and you can see all the logs about that experiment, etc. And when you are doing your experiment, you do a lot of iterations, right? So for an example, you have an experiment which is using a machine learning algorithm called as random forest. And within random forest itself, you will try different iterations by optimizing some parameters, or you will have different runs within that random forest algorithm itself, right? So how to organize all that runs by keeping all the parameters, what exactly the parameters which is used for that experiment and that particular run, what is the metrics coming out of that run, is it better than the previous run, and what is the version of that run, etc., right? So it is very difficult to manage all this kind of a different experiments when you are dealing with a notebook or simply a development environment or an IDE like a VS Code, any other Python IDEs, right? So it is very difficult to manage all these things in a local machine, right? And similarly, the data has a this when you're having the model building exercise, right? You have a lot of metadata and the data lineage, right? So when you're experimenting with a model, you have a specific version of one data will go to that model for training and building, right? So you should have a lineage between your data and your model or experiment, that which exact data is went to that modeling experiment, so that you can see what exactly happened with that data. And in terms of model building, you have to provision your infrastructure, right? So you should create a GPU or a CPU machine on the fly, or your the infrastructure team will create it for you, and it has to be given to you. So you have to keep track of all these things, right? Which what is the feasible infrastructure which is required for my model building, etc. So the model building activities, all these points which will come into the model building activities will be covered in MLOps. So Azure MLOps provide an efficient way of logging all your details with respect to your experiment and trials. Okay. Next, come to the model management. So once you build a model, assume you build a best model and you are going to share it. So usually what it happens, you share that model, you have a pickle file or some other model format file, you just share it offline to the infrastructure team or DevOps team. You just kept it somewhere and they will take it from there, right? So that is not that is not an efficient way of transferring your model artifacts or model for deployment, right? So that offline movement of the model from your local machine to some cloud machine is not the correct way, right? So that because you are doing it, so there is a manual effort involved in it and it is not organized, right? So in model management, Azure machine learning platform offers a central location with a proper versioning. So when you are building different versions of the model in that central location, you can manage that model. You can see what is the name of the model, what is the metadata which you created for that model, what is the version of the model, and what exactly the model talks about, what is the metrics coming out of that model, the plots, the hyperparameter, whatever you used for building that model, etc. Everything can be logged into Azure Machine Learning as part of model management. So you can come to that model management um, uh, platform or the framework which Azure offers, and you can see how many models you built and what are the different versions of the model, what are the different artifacts which is associated with that model, what are the different other details and metadata associated with that model, right? It's all centrally located. Next comes the model profiling. This is not a mandatory step, but we usually do model profiling once we have a model. The next phase is we have to deploy that model into different environments. Now, model profiling, what it does, it will try to understand the minimum memory and processor requirements for your model. So we just load the model into memory and we send some sample requests to that model, so that we can assess what are the exact memory and processor requirements for my model to be hosted into a QAT environment or a production environment. This will help me identify or size my infrastructure so that I can share that information with the infrastructure team, so that they can set up a proper infrastructure in your QAT and production. So you will not get a surprise if you just try to deploy the model in QAT and prod, and your model will say that this is not a GPU and I cannot run on this model, this system. So you will not get such surprises if you do a model profiling. So you will get a proper understanding what are the infrastructure requirements for your model to run in an environment. So that can be shared to infrastructure team as well. So this model profiling is another part where we can do with this machine learning operations with Azure. The first part, if you look at the first part, this is completely on the CI part of it, continuous integration part. You starting from the code management to the data management, then to the model building exercise, and once you build the model, to the model management and the model profiling part. This the first series you can segment it as part of your continuous integration pipeline. So I will show you how you can build a continuous integration pipeline using Azure DevOps, starting from your code management to the model profiling, where you can get your data version, get your data into a central location, build your model, use that model into a central location, and how to profile the model. So the first series can be built. I will show you how to build this first series using Azure continuous integration pipeline. Okay. So here comes our build part. So once we build the part, we have a model. The next phase is to deploy the model, right? So into an environment so that real-time predictions can come and your model can serve that predictions, that inputs, right? So second series, there are two phases. One is you can see the color, the orange color talks about the deployment part of it. So as part of the deployment, once we have the model, there should be a model governance phase, right? So you cannot simply build a model and even though you are getting some good metrics out of it, so in an enterprise you cannot simply deploy that model into production or without any approval, right? So the model governance phase should be there where you have to keep different approvals, life cycle of the approvals where somebody else can look at that model and its performance and they can accept and reject the model uh, before it gets deployed to the into any other environment, right? So model governance an important phase in the machine learning operations and in an enterprise itself. So we should have a proper model governance in place after you build the model. Then comes the model deployment, right? So in this model deployment, so it is not possible in an enterprise level where you can simply create a model and you create a Python Flask or Fast API interfaces on top of the model by just writing an application and load your model into the memory and just deploy that application. That's not possible in enterprise because there are a lot of flaws in it. Why? Because if you do that, then you are going to handle all that things. You have to manage that. You have to manage how that application scales when the load of data coming as part of the real time input will become high. So scalability is one concern for enterprise, right? How to scale it up when there is a lot of load coming for that model for prediction. So and there is another concern is like parallel processing. How will your API endpoint will be able to deal or process multiple inputs at the same time? A lot of constraints will be there. So if you're doing such kind of an application deployment, then you have to deal with all the scalability, the parallelism of that endpoint, and the fault tolerance of that endpoint if the model endpoint goes down. So how will you make sure that the model, the API endpoint never goes down so that your application will have a zero downtime, right? So managing all these things on that created Python Fast or Flask endpoint is very tedious because you have to manage it. So we usually don't do that. So we use enterprise level scalable platforms like Kubernetes or any other ways in a Docker way or in a Kubernetes way. And we deploy our models into that so that the scalability and the fault tolerance and the downtime part of it being taken care by that environment or the infrastructure itself. So we don't need to take care of all these things manually, right? So the model deployment talks about that, right? So in the model deployment itself, you have to deploy a model with the different versions so that when there is a real input coming in for prediction, you can route saying that, okay, fine. So some part of this input load will go to the model version 1 and some part will go to model version 2. We can do all that kind of an A/B testing with if you manage your model and version your model in a better way once you deploy the model, right? So this model deployment is one phase where you can enable machine learning operations so that you can seamlessly deploy your model and organize your model deployment. The next part of it is you can call it as a smoke test. This is not a mandatory step, but it is advisable because once you deploy a model, what you're ultimately going to do is you are going to share that endpoint, right? It might be a REST endpoint or any other protocol environment endpoint. That endpoint has to be shared to the application team, and they are going to integrate that with that endpoint by sending some dummy request and response or something like that, right? So before sharing that endpoint, because you are going to deploy this model in an automated way using a continuous deployment pipeline. So you are not going to deploy it in a manual way and you are not going to test it in a manual way, right? So I'm going to show you how you can deploy this model using Azure continuous deployment using DevOps. So you are going to deploy this model in an automated way. So once you deploy the model, how will you make sure that the model is working fine, right? So there should be some smoke test has to be performed on the created model endpoint. So you just send some sample request to make sure that the model endpoint is working. So before you share that information with the corresponding application stakeholders and integration team, otherwise they will come and complain your model endpoint is not working. So you should include such kind of a smoke test in your continuous deployment pipeline, where you make sure that the deployed model endpoint is working by sending some sample request and request and getting the response. You can include some of the positive and negative unit test cases with regard to your model prediction as well. You send some positive predictions and or you send some input and get the positive prediction or get a negative prediction. Some kind of a unit test you can create as part of this phase. So once you make sure that you have a model deployed and the endpoint is working fine, then the another thing is usually we stop it here. We don't enable data capture or anything in the traditional machine learning project, but this is a very important step, because the data capture means once our model is getting deployed in production, we have to continuously monitor the incoming data. Okay, so you can see one's module in green, that is called the drift monitor. So once we deploy a model in production, that is just the beginning. Okay, so but usually a lot of people, you just build a best model after doing a lot of experiments, and they just deploy it and they think that that is the end of it. No, it's not the end of it, it's only the beginning. So we are not sure whether your model actually captured all the possible variations of the data in real world, right? So you got some data and you built a model, you have different holdout data sets or whatever it is, and you made some you had some consistency check as well, and your model is well generalizing, but it doesn't mean your model will work better in the real world scenarios, right? So once the model is in production, you might get different deviations of the data. So you have to continuously monitor your model for performance degradation over a period, right? So in order to do that, you have to capture the real world data. If you're not capturing your real world data as part of your machine learning operations pipeline, then you will not be able to analyze the real world data that is coming in and why your model is performing. You can analyze, right? So your model is performing in a generalized way, or your model performance is degrading over a period. So data capture is one important module in an enterprise machine learning, where you have to capture the real-time data coming into your endpoint and what is the predictions coming out of your model. So you have to capture this. So once we capture this on a real-time basis, then we can further analyze that using automated drift monitors, or you can analyze, data science team can look at that captured real-time data which is coming to that endpoint on a periodic basis, and they can analyze the data and they can identify the drift manually. There are different ways to do that, or you can enable different data drift constraints or monitor techniques which Azure MLOps provides. You can enable that, or you can extend that to bring your own constraints or your own logics, how to bring your drift, okay, how to identify the data drift. Okay, the final part is post deployment. As you can see, the green, this is not part of the deployment. The blue is part of the integration, the continuous integration part of it, and the orange is part of the continuous deployment. Once we deploy the model and once we enable the data capture, the next phase is data drift monitor. This will come usually post production. Okay, you productionize the model, real world data is coming in for prediction, and this is an important step in the enterprise ML, where you have to continuously monitor the incoming data for any drift. Drift means any changes in the data, any changes in the data, in the real world data, which causes your model performance degrade over a period. That is called as a drift. Okay, so it can be feature attribution changes, or it can be the distribution change for a particular feature. It can be some data quality issues coming part of a feature, whatever it is, right? So it all these things can happen in real world. So we have to continuously monitor what exactly is happening with the feature. Is the distribution which is changing? Is there any data quality issues coming in real world? Is it the feature attribution changes happens? Is the feature importance is getting changed over a period of time? Right, all these things has to be monitored real time, so that you can go back to your model. This drift is an indicator to the data science team, and they can periodically analyze this, and they can go back to the modeling exercise, and different versions or better versions of your model will come, and that will be rolled out in production. Okay, so this is what fundamentally happens in a real world ML project. And how to organize this, I will show you how to organize this with machine learning operations. Okay, so machine learning operations is not DevOps. So here, using machine learning operations, I'm going to address each and every block what you see here. right? Each and every block, how to automate that, how to manage it, how to trace it, how to extend it, and how to scale it. All these modules can be incorporated into machine learning operations. Okay. Before getting into the demo, so I will just wanted to make you understand some of the terms which Azure machine learning uses. They call it as, this is just for an education purpose, right? So they call it as a workspace, where the workspace is a logical abstraction of all your machine learning assets. So workspace is the high level. So first you need to create a workspace. So that workspace can be a project based or works. Yeah, that usually has in is a project based, right? So if you are working in different projects, this machine learning workspace will help you organize your project. So you can define a workspace name, and you can bring all your assets, machine learning assets, what you do with Azure machine learning under that workspace. So everything is completely organized, right? Next come compute targets. Compute target is another term in machine learning, Azure machine learning, where what they call it as a virtual machine. It can be used for training, or it can be used for development, or it can be used for a deployment. So you have to create a virtual machine in Azure to do the training, deployment, and development of your machine learning pipelines, right? Next, they call it as data set. So Azure offers different types of data catalogs, right? So you have lakes, you have blob storage, you have some other SQL-based Synapse, and all those kind of data systems are there. So if you wanted to bring the data from all these wide varieties of data sources into your machine learning pipeline for building a training or building a model or something, right? So this Azure machine learning should have a seamless integration with all that data catalogs or whatever the data services available from Microsoft, right? So the machine learning should integrate with that. So there is a concept in Azure ML called dataset, where it creates a reference and metadata. It is actually a metadata and reference to the data at different data sources. So you don't need to worry about where actually your data resides. It's in a blob storage, or it's in a ADLS, or it's in an SQL server, or it's in Synapse, or wherever it is. So you don't need to worry about that wide varieties of data sources. You define a data set in your Azure machine learning workspace, and this data set will create a high level abstraction or connection between your data and your workspace, so that you can seamlessly call that data in your workspace, machine learning workspace, and experiment with it and create your models on top of that data, right? Then comes to the experiment. So experiment is, you are going to do an experiment, and you just name that experiment. Say for an example, you are going to build a model using random forest. So you can say it's a random forest classifier, and inside that random forest you will have different runs. Each run will be, right, you will do different hyperparameter optimization or different experiments or different trials within that random forest using that random forest algorithm itself, right? So you can log all that things as a run. So each run can log your model metrics, the images in terms of whatever the plots which you're creating, and the model outputs or the code snapshot what you have used for that run from the Git repository. And you can include the explanations, model explanation, and the model fairness. All these things can be logged as part of the run, right? The next comes, once we build that experiment and run, you have the model registry. So the model registry is once we have the model and you are going to use that model in deployment. So you have to register that model in a central location. So model registry is the point, the location where you can bring your model from your experiment and run into a central location with the proper versioning and proper metadata and proper lineage. So this lineage will tell you what exact data I used for this training, what is the arguments which I shared for this modeling experiment, and what are the hyperparameters used, etc. Whatever information, metadata information, and lineage information associated with that model can be registered in that model registry, so that everything is completely traceable. Next comes the model profiling. So model profiling talks about identifying the memory and processing requirements of your model to run in different infrastructures or environments. So this will help size our infrastructure when we provision it for different environment deployment. Then comes the model deployment. You can deploy a single or multi-model deployment usually in Azure container instances and Kubernetes. So these are the two provisions. You can deploy it in a normal standalone virtual machine as well, but that will not be self-managed. You have to manage it. But if you wanted a self-managed service from Azure, then you have to deploy your model into container instances or Kubernetes. But container instances are not advised for production deployment. You can deploy it into container when you're just using it for dev environment. So because container instances will not provide you that kind of a guarantee of scalability and the fault tolerance, zero downtime, etc. So in order to go with that kind of a functionalities, then you have to go with Kubernetes. So Kubernetes is preferred in the in production deployment. Okay, so then comes the real-time data capture. So this facility enables us to capture the input data which is coming to that endpoint, and the output coming from the prediction. Everything can be logged in a real world or real-time manner, so that we can make use of that captured real-time data for identifying the data drift. So the next component is a data drift component, where you can see there are inbuilt a lot of capabilities of Azure ML, where you can have standard data drift. You can configure it on your the captured real-time data with your model. So you can identify by default where there is any changes in the data in terms of data quality, the distribution changes, or is there any natural data shift happens over a period of time, the correlation between the feature changes over a period of time. So all these things can be handled with the data drift, and Azure ML comes up with a lot of this kind of a default functionalities, and you can enable that on top of your deployed model, and you can even extend that capabilities to add your own custom logic as well. So this is the overall architecture what you are going to see in this demo. So what you can see, the code repository is getting integrated to Azure CI, sorry. So Azure DevOps CI, continuous integration and continuous deployment. And here you can see the different part of the machine learning operations module. You can see in the bottom, code management, data management, model building, all these are different modules comes under machine learning operations. And so what we are going to do is we are trying to bring all these modules. We are going to enable all these machine learning practices and best practices and standards into our pipeline. And we are going to build a CI pipelines, DevOps CI pipeline on top of your machine learning project, so that your integration is automated. So you just come to DevOps pipeline, Azure DevOps pipeline, and you start your CI pipeline, and everything will happen automatically instead of you do all these steps individually, right? So here we have Azure code repository. We integrate that code repository, and we right now in this demo we are going to use a CSV data, and we keep that into blob storage, and we register that data using the data set. And all these things what you see here will be completely automated. We are not going to do any step manual. Okay, so CSV is getting brought to blob storage. That will be done automated using the CI pipeline. We have different steps in the CI pipeline. We register that data as a data set, and our model training happens with as a task in our CI pipeline. So there it will create a compute instance on the fly. So, and it will create an experiment run. It will make use of an external libraries. I'm going to use sklearn. I'm not going to use the native algorithm supported by machine learning, Azure ML. So you can use that, or you can bring in your own external libraries. And we build a model, and we log all the different metrics, output, etc., into the machine learning pipeline. And then we register the model into model registry. All these steps will happen, is going to happen automated. So we are not going to do anything manual. And the scope end here for CI, we take whatever the necessary information required for me to deploy this model into the deployment pipeline. I will just take that configuration and metadata files, and I store that into DevOps pipeline artifact. So this will be our end of the CI pipeline. Once the CI pipeline is completed, I have all the necessary information and the metadata files and the configurations which is required for me to deploy that model into Kubernetes or container instances. So the scope of CI pipeline in here. There comes the CD pipeline, right? So this is a separate pipeline. So CD is separate. where it will take all the artifacts from the DevOps pipeline for that particular CI, and then it will take the model from the model registry. You're not going to upload your model artifacts or anything. So it will directly connect to the model registry and take your model with appropriate version, and it will deploy that model into Kubernetes or container instances, and it will create a REST endpoint. So you are not going to create a REST endpoint using any application, Python, Flask, or Fast API, or any other application. You are not going to build a REST endpoint. You are just providing which model I should deploy it from the model registry, and what is the version of the model I should pick from the model registry, and the Azure Machine Learning will create a REST endpoint for you, and you can enable data collection in your CD pipeline, and data drift will comes after that. Right? So this is the overall architecture what we are going to do. So here you can see that in the bottom line, you can see all these machine learning operations modules or standards are getting addressed, and it is getting automated by the CI and CD pipeline. Okay. So this is the Git repository. You can make a note of this Git repository where I open sourced all this artifacts which is related to this demo. So what we are going to do is we take Iris dataset and Iris dataset CSV file, and we build a model using this Azure machine learning, and by enabling all these machine learning operations what you have seen before, and how to bring that machine learning project, how to automate that machine learning project, Iris machine learning project using DevOps, CI, and CD. Okay, so whatever I do here, everything is put in this repository. You can reproduce what I do here with the help of this repository. Okay. Right. Right. So here comes, right. So here, this is the DevOps pipeline. I have a repository, and you can configure the repository. Okay. So you can bring your codes into this code. Okay. And this from this repository, we are going to build a CI pipeline. And in the CI pipeline, what you see, this is one CI pipeline. You can see the steps. So we have different tasks in the CI pipeline. We are going to use a Python 3.6 version, and we are installing default Python dependencies. Okay. What is required for this to run, and then all my this in the CI pipeline, what I'm going to do is I'm going to use Azure CLI machine learning extension. So there are two ways to do this MLOps with Azure machine learning. You can either use Python SDK. They are providing Python SDK, and you can do all this operation what you see here in your CI pipeline using Python SDK. You can do that, or you can use the same operation with Azure CLI. Since it is a CI pipeline, continuous integration pipeline, and the people who are working on this, the DevOps people, doesn't wanted to look into the Python code or something. So it is easy. It is better if you can just enable all this task into the CLI way, so that they can easily make use of it, and they can easily understand and change it instead of looking into a Python program and change the code. So I made use of Azure CLI's machine learning extension to run all this, create all this task and run it as part of the CI pipeline. But you can use the Python SDK, and you can, instead of using CLI, you can use Python SDK as well. Okay. The next step is I have to, the assume you are going to deploy this experiment and deploy this machine learning project into another environment. So there is no need to go to the Azure portal and create anything from here manually. You just come to the CI pipeline and create a workspace. That is the first step we need to do, right? So that is a task in the CI pipeline where I define a lot of CI variables, right? You can see the experiment name I defined it as Iris experiment, and I created a variable group. Okay, so here I mentioned what is the machine learning workspace. So if you wanted to build or just move this experiment to another workspace, then you can simply edit this, and it will create a workspace name, Iris workspace demo. And I'm providing all these variables, right? Which resource group I'm using, what is the compute target machine I should create, right? What is the name of the compute target machine, what is the minimum and maximum nodes, etc. So all these variables you can define in your pipeline, and you can call that variables in your task, so that if you wanted to extend this pipeline to another environment, you can just go to the variables and change it and run this pipeline. It will create necessary resources in that infrastructure, right? So the first step is to create a workspace. When you are starting with the machine learning in Azure ML, you have to start a workspace, create a workspace. So I'm creating a workspace by taking the variables which I defined and using the Azure CLI commands. If it exists, it will not create, and if it doesn't exist, it will create a workspace with that name. Then the next step is I'm going to create a compute target machine. This is required for my training script to run. So this you can create on the fly, like within your CI pipeline, or you will get this compute target machine from your infrastructure team. So not always we'll get an option or provision to create our own compute target machine, because that will be completely owned by the infrastructure team. So based on the organization's policies, right? They will only have the permission to create the compute targets or VMs, and they will share it with you. So in that case, you can even refer that compute target machine here, or if you have a freedom to create your own compute targets, you can create on the fly a compute target machine or a VM in Azure ML, or you can refer whatever is given by your infrastructure team in this pipeline. Okay, so here I'm going to create a VM using this pipeline itself as a task. So it will create a virtual machine on the fly when I am going to run this pipeline. Okay. Then the data. So in this MLOps practice, right, we usually don't refer the data locally, right? So we have to keep the data into a central repository, whether it be in a blob storage or in a data lake or any data services provided by Azure. You keep your data there, and when your training starts, you have to bring the data on the fly and you have to train your models. So you don't have any any way of locally referring a CSV file in your Python script, your training script, and build a model. So that is what we are going to avoid with machine learning operations, right? So you have to bring your model into, bring your data into a central repository. So what I'm trying to do is I'm uploading the CSV file into the blob storage. Then I'm creating some necessary folders in my virtual machines, and then as part of the iris training step, I am running the training script. Okay, so if I show my code, right. So this is my training script. Okay, so this is my training script. I'm going to invoke that training script from this repository. This is the repository, and using this Azure Machine Learning CLI, we are going to submit that Python training script on the fly from the CI pipeline. So training will happen on the fly. Once the training completed, we will get a model, and I'm going to register that model into Azure Model Registry. Okay, then this is the end of the CI pipeline. So I have to make sure that in order to run my CD or the deployment of this model, I have to copy some of the necessary information and configuration file from this integration pipeline, which has to be shared to the CD pipeline. So I'm copying all that necessary information from the CI pipeline to make it available to the CD pipeline, and I'm just publishing all that things as part of the pipeline artifact. So once you do this, I might not be able to run this right now because of my Azure subscription, it is expired. Okay, so once you execute this, what you can see is you can see each and every step what is getting executed in your CLI, the logs of that, the status of that, whether it is successful or failed. So you can see all the trainings, everything is happening. This is your training step where it is happening, and it is provisioning the environment. It is installing all the required libraries, which I specified in my dependency file. And then it is started creating the job, right? So then registering the model, etc. So you will be able to see all that information step by step, uh, what exactly happens with each and every task or step, right? So here you can see everything is successful. So our training script is completed successfully. We have a model, and that is getting registered into the model registry. So once we have this, you can see that we are storing the required configurations into the into the pipeline artifact. So these are the required configurations which is for my deployment pipeline, because deployment pipeline is a separate pipeline here, right? So I need to take the AKS or ACI configurations, the conda dependencies, what is required to run my deployment script. My external libraries are mentioned in this YML file, and different other required uh, configurations, right? So this is stored as part of this pipeline artifact, right? So the CD pipeline start from pulling the configurations from this pipeline artifact, and it will take all this information, and it will build a CD pipeline on top of this. Okay. So the CD pipeline looks like this. It should be look like this in production. Okay. Different environment. So you can see we are connected to that pipeline artifact. Okay, so this is the artifact which we talk about as part of the CI pipeline, where the CD pipeline is connected to that artifact. Okay, so it is right now it is having access to that required configuration files and the dependency files, the scoring script, etc., in order to deploy that model. And you usually have different environments like this, right? UAT environment, production environment, etc. So you can have an approvals. You can set, this is where you have the model governance. You can set pre and post approval of each phase, and you can tell, you can set who is going to approve this, and the person who is going to approve it, who can comment it, whether while approving or accepting or rejecting, they can comment what exactly is going to happen. All these things are tracked here, right? So here you can see all the pre and post approvals you can set as part of your pipeline, right? So once the post and pre approval is accepted, then only it will go move to the next phase. So we can make sure that model governance is in place, where it will keep track of which model and which version is going to UAT and production, and what is the performance, everything is fine, working well, so that you can move the things to different environments. So this is model governance, right? And as part of the CD pipeline, this is a CD pipeline, right? Deployment pipeline. And here also we use Azure CLI machine learning extension to execute all our tasks. And since I don't have any provision for AKS, since I was with free subscription, I cannot create an AKS cluster. So we are trying to deploy this Iris model to container instances, and this is the command line using Azure ML CLI to deploy the model, right? So everything is parameterized here. So if you wanted to make any changes, you just come to variables, and variable groups are referred here, right? So you can change the variable groups here, and you can make those changes here without changing anything. Okay, without changing the program or without changing the task, etc. You can define all the variables and refer those variables into your task, so that it is seamless, right? So DevOps people can come and change the variables per requirement of when you're trying to deploy this into different environments, right? So this is a statement to deploy this model, and all these things, each and every picture, and the commands, and the step-by-step approaches, everything is I open sourced it in my this Git repository. So you can just replicate what I show here by just looking at my repository and taking the artifacts from here, right there. Right. So once we deploy the model to production or any other environment, the next step is mock test, what I mentioned, right? So here also we automated that process of we have an endpoint, and we don't even know the endpoint name, right? So this is happening automatically. This step will create an endpoint, and we just get that endpoint automatically from here, and we just execute some mock test. I will show you some of the smart test which is part of my repository. So you execute some smart test to make sure that your environment is, the endpoint is working fine, and it is accepting the request and getting the predictions properly. Okay, before you share it with the application team for integration. Right. Now the next phase is you have some the smart test or unit test cases on top of your endpoint, and you just publish the test results into the CD pipeline, so that it is organized. You can see that out of n number of unit test cases, how many passed and how many failed, you can have a report of your test cases, and you can publish that as well here in your CD pipeline. Okay. So once you execute the CD pipeline, what you can see here, right? Yeah. Here you can see okay. You can see the test cases, test results. That's what I was looking. Yeah, you can see in analytics tab, you can actually see the test cases, right? So since I rejected some of the, here you can see, right? So you can see the test cases. You can see I have 2 test cases running as part of that Python script, and 2 of it is passed. And you can see the other results. You can download this result and see, right? So if you look at this endpoint, this CI and CD pipeline, what you see here, where in your CI pipeline, you automated everything starting from, okay, so it did. In your CI pipeline, you automated everything starting from creating a workspace, creating a compute target machine, uploading your data to a blob storage, and train your model, and then register the model into model registry, etc. All this thing, all this task has been automated, right, in your CI pipeline. And in your CD pipeline, you have automated deployment of that model to ACI or AKS. You automated that, and you automated the smoke test part of it, and you published this result as well, right? So you have covered most of the MLOps within this task itself, right? Right. So right now, I'm sorry, I might not be able to show you how it looks like in MLOps, this Azure machine learning. Let me see whether I can show you quickly. Not related to this iris deployment, I will show you some of the other things. Maybe. Let's see. Okay, so here you can see this is what it happens when you are deploying your model or running that CI and CD pipeline. It will create different experiments, and you can see some of the experiments here, right? So all these things will get created automatically once you execute your CI and CD pipeline, and you can see all the details about that pipeline, right? So the metrics which is coming from that model, you are registering that metrics in the pipeline, and images. I'm not plotting any images here. You can see all the output logs coming out of your experiment, right? You can see everything, and you can see the snapshot, the code snapshot, the part of the code what is being taken for your training. Everything is logged here, and I haven't enabled explanations and fairness. You can enable that as well. And in the model registry, you can see what is the name of the model, version of the model, where it is registered, and which experiment it is related to, which experiment created that model, which run ID. Everything is having proper lineage. If you look at it, proper metadata and lineage is maintained. And you can see the model artifacts in terms of your model files, the endpoints which is created from that model that is being here. So it means this is the model name, and this is the endpoint which is created with that model. So this is what the beauty of MLOps, where we are keeping track of all the things, and we keeping track of the lineage, right? So that it is easily traceable, right? Endpoints will tell you what are the different endpoints which is running right now, its state of that particular endpoint, etc., and all the other steps, right? So this is my, okay, so this is how it looks like. I might not be able to show you as part of my iris training. I suggest you just take this GitHub repository and you replicate this CI and CD pipelines in DevOps, Azure DevOps, and you execute this, and you will be able to see all that workspace runs, experiment models, etc., in your portal, Azure portal. So I cannot show you right now because of my free subscription has expired. Okay, right. Okay, yeah. Yes, I think it's almost 1 hour. So you take this repository and you just try to replicate this and let me know if you're facing some issues. So yes, this is how we organize machine learning pipelines using MLOps. So in order to iterate, MLOps is not DevOps. MLOps is not only talks about the model data driven approach. MLOps is a complete lifecycle management that you might already understood that we have addressed various modules within your machine learning pipeline and how to bring an organization or management into that process so that everything is traceable within your machine learning project instead of doing something in a Jupyter notebook with nobody knows what is going on, right? So that is what machine learning operation is. It's a very broad term, and I hope you were able to connect what I have told you and I have shown you today. So that's all from my side. Thanks for listening to me. It's been 1 hour. So if you have any questions, I will try to answer that, and you can look into my repository and replicate these steps. Okay. Yeah, that's all, Vishwas. Thank you. Over to you.
Yes, sir. Thank you so much for this amazing webinar. It's been a wonderful thing that, okay, the general CI/CD pipeline can also be leveraged to our ML, and also we won't get bored of learning containers or the Kubernetes at the end of the day, because it is somehow getting deployed through these software somehow or the other. So thank you so much for that amazing session, sir.
Thank
I
you.
think probably everybody is in the mood of IPL, and I think probably
Yeah, yeah, sure, sure,
we are
sure.
lucky that we had some of the participants here. I thank you so much for all the
That's
participants.
fine.
Out to you, because you even found today interesting and you came for the webinar. Yeah. No, thank you so much, Srijit. Rama K. Prayaga. Thank you, sir. Okay. Can you share the deck? Okay. I will share the deck in the comment section, and also it will be in the description of this video. Do check out this video afterwards also, so that you will get to know everything. So your sir's GitHub repository is here, the MLOps, so you can just go on and get that repository and you can start working out with it. So like I had some doubts, like I
Sure,
think I can ask some
sure,
doubts.
sure, sure.
Like there are ways in which containers also has the data sets today. My means like you can deploy it on a container instance and also can get the data sets. Like,
Mhm.
is this supported in MLOps now?
Yeah. So in Azure, this production level deployments, they don't prefer container instances because the disadvantage is you cannot guarantee the scalability part of it, right? You can deploy it as a Docker container and using container instances, but production, nobody prefers that because in production you need scalability, right? So you need fault tolerance and we need zero downtime of that application. So this container instances will not have that features, and if you're deploying it into container instances, you cannot enable data capture. So it means you cannot do data drift in Azure machine learning. So you have to go with AKS for production deployment, but for dev deployments, you can go with the container instances.
Okay, like how to scale the models if it's like in like we still know that we have to deploy the model in the real time and it has to make a real time decision. Like today we have Kafka, we have other instances which have come up. Like Kafka is also available in Azure. Like how to
Right,
leverage these real time data and make a prediction, and also, and sometimes real time data can't be an outlier, we have to train using that also. So how
right,
to leverage the outliers in the real time, and also how to leverage the real time data that we are receiving for our application, let me
right.
just say app or a website or something like that.
Right. So here, right? So that's what, right? You can create a virtual machine and you can train your models in that virtual machine standalone, or you can leverage Azure Databricks. Okay, so you can leverage all the capabilities of real-time processing using Spark or Kafka, whatever they offers in the Databricks, and you can run your experiments and create a model in your Databricks and bring your real-time data into your pipeline instead of using a blob storage. So that is also possible. So did I answer your question or?
Yes, you answered it, Azure
So
Databricks is
usually,
also good.
Yeah, usually coming to the improvement of the model, the data drift indicators, what they provide or what we can extend, will give you some indications to the data science team. It's not suggested that you automate, you can use AutoML, but still I prefer to look at the data drift and manually and see whether it's an actual candidate for a retraining or not. So if you don't have this data drift indicators, right, then you have to collect the data manually and you have to run through that data like you do the EDA. You
Yeah.
have different set of analysis you have to do. That is a very tedious effort and repeated effort, right? So here as part of the data drift, they automated that part and they will give you some basic information about what happens with the real-time data so that you can you can look at it and you can make a decision. You can make an early decision. That's what I say, that whether you wanted to work on your model for a better versions or not. So instead of your business is complaining you that, okay, your model is not working well. So you can take an early decision and you can prepare for a next version of the model looking at the data drift.
Yeah, sure. And also one more question from Rama K. Prayaga. So you mean it is expensive, the MLOps? I think she asking about the process of MLOps, I think so. Or is regarding the other question that I had asked, like in the real time events and all. I think probably for that she might be asked.
MLOps, first we need to understand, right? MLOps is as a best practices or the standards which we need to do when you do a machine learning project. Okay, so MLOps is not a physical component. Okay, so it is a standards, right? So when you talk about data, the MLOps standard is you have to centrally locate, store the data, and you should have proper versioning of the data. That is what MLOps, the operations part of it, right? Standards which they are defining to each and every module. So when you have a model, you should not keep that model in your local system. You should keep that model into a central repository with the proper versioning and proper lineage, right? Which data used for building the model. So MLOps is defining certain set of standards, and using Azure ML or Amazon SageMaker or Google's platform, they build their platforms on top of the standards. Okay, so their platform, if
Yeah.
you leverage, then you can implement that. You can physically materialize that, right? So otherwise, MLOps is still a standard or best practices or in theory, but these platforms will make you enable implement that by following that standard in real world projects. So I didn't get that why it is expensive. Is it
Yeah, she is saying in terms of like in process, like AKS has to be in AKS has to be running, ACI has to be running at the same
it
time
is
because yeah,
yeah.
it's a little expensive. That's for sure.
Yes,
Anywhere.
that is there. That is there. So two things, right? So once you are going, you have a flexibility of having that cost thing from your management. Then definitely you need to go with enterprise. Then if you don't have that cost, if you have that cost issues, then you might need to leverage some of the open source machine learning MLOps tools called ML Flow kind of a things, and you can still do this MLOps within your local system as well by leveraging some of the open source tools libraries, right? So instead of going with enterprise ML.
Yeah, Aina Bajaj is asking a question like, if we want to run a model, if we want to run our model available 24/7, instead of load it again for each example, what is the best approach that we can follow?
Okay, so we usually don't load the model for each example. So if you do that, say just create a Python application, REST endpoint, Flask or this Fast API application, and if you keep on loading your model for each of your example, then you will end up in a memory exception because that is not required, right? So you have to load your model one time, right? You have to load your model once when your application is coming up, and you have to make use of that model's reference to predict each and every examples. Otherwise, you will end up in a memory exception. So we usually don't do that. So that is not the way. So you load the model once, and use that model reference to um, predict each and every example coming to the endpoint. That's what we usually do.
And also, moreover, this is ML ops where you actually do it in when you are in a production environment. When you are in
Right.
deploying, it's a different environment. Like
Correct.
when you deploy it on an application, let me just say it's a Flutter application.
Mhm.
You have to write a proper YAML file in which all the dependencies are there and everything. But in MLOps, you can really change the environment over the course of time. uh,
Exactly.
it differs when you're applying it, and also different file formats of your model also, CKPT, PML,
Yeah.
whether it's H5, they
Mhm.
start changing, right? So yeah,
Correct.
it's a production environment, it's not a complete deployed environment, so it's a difference. There's a
Yeah.
difference
Correct.
there.
Correct.
I think there are no other questions here. I think if you guys have any questions, please do drop it out now, or else we'll be ending the broadcast now. So yeah, 10 seconds is the lag. So yeah, please do drop in some questions in the comment section so that we can cover those questions also.
Yeah.
I think there's no questions. I think thank you so much, guys, for staying up and being this energetic at least even during these days, and thank you for supporting us. And this community is where we are targeting all the tier 1, tier 2, tier 3 cities. We are in 100 plus cities now, so you can join by using the banner which is just flowing down here, and you can just reach out to us. You can reach out to us for your articles. You can reach out to us for your projects to be posted on the Microsoft newsletters or anything. You can just reach out to us and we'll help you with that. Thank you so much. I end the broadcast.